Hello, welcome to the series of electronics engineering, and we are going to discuss about concept of energy band diagram. This is very useful while classification of different materials like semiconductor, metal and insulators. So we can classify these all materials according to the concept of energy band. So what is this that we are going to discuss about? So ultimately, if we will say that what is the material, so material can be called as the combination of molecules. Material can be called as the combination of molecules. So material are the combination of molecules. If we will say that this is a material, so we can call it like this is the this is the combination of different molecules. This is the combination of different molecule and so on. So this is this is a material, and we can call it these as these as molecules. Okay, and these all molecules are the group of atoms. These molecules are the group of atoms, means ultimately we are having different atoms inside of these all materials, these all molecules. So this is the atom, and most importantly, each and every atom is having its own nucleus. This atom is having its own nucleus. It is having its own nucleus. This is the nucleus of this atom, and in this nucleus we are having protons in the nucleus. Here we are having protons and neutrons. Protons and neutrons. In the nucleus, we are having protons and neutrons, and surrounding to this nucleus, there are different orbits in which electrons are moving because of their energies. So let's say this is the first orbit. There are many orbits surrounding to this nucleus. So let's say this is the second orbit. This one is the second orbit. So in these orbits, electrons are moving. In these orbits, electrons are moving because of some finite energy. In these orbits, electrons are moving. There are so many electrons that are moving in these orbits, and there is some finite energy. These are having some finite energy. Because of that, they are moving in these orbits. These all electrons are having some finite energy. The charge is negative, so we can write like minus. So this is a nucleus in which proton and neutrons are there, and surrounding to this, electrons are moving because of their energies. So simply we can say that electrons are bounded because of some force between these two. This is the positive because of this neutron is neutral, so this nucleus is positive and this electron is negative. So there is a bonding force between these two. That's why they are moving like this. And simply, if we will say that which particular electron is having higher energy, so we can see here, this is the radius of this orbit. This one is the radius of this orbit, and this is the radius of third orbit. So ultimately, these electrons are traveling a path of 2 pi r1. In second orbit, the total path is 2 pi r2. This is the circumference. This is 2 pi r3. So last orbit electron is traveling this much of path. So as we know, so electron which is having more energy can travel too far. So the electrons in the last orbit, electrons in the last orbit are having this much of, are traveling this much of circumference, so electron energy in this orbit is higher than the electrons orbit in this second orbit, and the least energy that are possessed by these electrons are of this orbit, this first orbit. So as we move away from the nucleus, the energy of electrons increases. As we move, we can write here, as we move away from away from nucleus, as we move away from nucleus, energy of electrons increases. So simply, the orbits near to this nucleus are having less energy, and orbits far from this nucleus are having higher energy. So there are some hypothetical energy cells where electrons are free to move anywhere in the material, and it is an easy task to dispatch an electrons from the last orbit of any material, of any atom. So we can easily dispatch these electrons. Whenever we provide some kind of heat or some we will increase the temperature. These electrons will become free because they are already having high energy, and as they get some part of energy, they will become free to move anywhere in the material, and then after they will contribute a current. So, in simple words, there are some energy bands that are having low energy groups, and some orbits there are some energy bands. There are some orbits which are having higher energy. So we can classify these orbits as. So this is the valence band, that can be known as group of lower energy orbits. This is the valence band. This can be called as valence band. What is conduction band? That is the group of high energy orbits where electrons become free to move anywhere in material. So this is the conduction band, and we can simply form this energy band diagram like this is the valence band. This can be called as conduction band, and the gap between these two is known as energy gap. And if we want to send any electron, from this valence band to conduction band, then we must require some energy, and that energy is known as gap energy, and this is always measured in electron volt. So we are writing here is 1 electron volt. Generally for silicon, the required energy in 1 electron volt. So we have written this. So energy required is in electron volt. And what is the concept of this electron volt, that we will discuss in the upcoming video lecture. So this particular gap, this gap is known as This gap is known as forbidden gap. Forbidden gap means there no charge carrier can exist in this space. No charge carrier can exist in this space. So this is the forbidden gap. This is the conduction band. This is the valence band, and energy required to send any electron of valence band, any electron of covalent bond to conduction band is known as gap energy. In metal, this particular gap is always zero. That means we don't require any kind of gap energy. So classification of these material we will discuss in upcoming video lectures. So easily here we can see we can easily dispatch an electron from the last orbit of atom because they are having very high energy. Similarly, the lower orbit energy cells is always having the energy less than the higher orbit energy cells. So this is the concept of energy band, and we will utilize this concept for the classification of materials like semiconductor, metals, insulators, that how can we classify these materials according to energy band diagram. So it is very important topic to understand. So thanks for watching this video, and in next lecture we will discuss about classification of material according to energy band diagram.